All right. Where do we end up at? I think we did this one here, the second one. So now we're going to the third one. You can see the answers already there, but let's just see how we got it. We're looking for A is what type of a side is A? It's a leg. Good. So make sure that that's on. Make sure that that's on the side with the other leg. So A squared plus 5 squared is equal to 13 squared. A squared plus 25 is equal to 169. Minus 25 minus 25. A squared is equal to 144.
Dang, so I just did that.
Yes. You bring up a very interesting question. What does the square root look like on the calculator? Because you're definitely going to need to know how to locate your square button. You also need to know how to locate your square root button. So depending on the brand, the square button will either look like this, it'll say y to the x, it'll say x to the y. You might see an x with like a little yeah, even though that's not actually, you know what, I take it back. These will work. These will work, but for if you use any of these buttons, you have to hit the 2 for square. A lot of calculators actually have a preset button for just second power, and it'll literally look like that. Okay, so just hit that. The number you want to square, and then hit that. Equals bam. Whoa. Take that, calculator. Yeah, I'm sorry. I thought when you asked it, you were asking me for the exponent button, because a lot of kids don't know where to look at the exponent button. Another common exponent button is this, which fun Friday fact. That's also what it looks like on a keyboard. On a keyboard, it's right above the 6th. Like, have you ever used Khan Academy? That's what they use for exponent. Shaughnessy knows. I thought you said you were a basketball cheerleader. For like JV. Those other cheerleaders there. Well, that's a square root. Square root of 144.
Hey, y'all going to the game tonight? Is it great?
I like it too, Wyatt. So.
Whoa, that's an eraser?
I thought it was sticky notes, so it's clear.
I thought it was just one.
Okay, what type of side are we looking for here?
Leg. No, not the leg, the slope thingy.
How do you know?
Because it has the right furthest away from the right one.
Sean, I thought you didn't want to talk to him. I gave you a chance to sit next to him. How do you know that that's the hypotenuse? It's a cross on the right angle, yeah. Curse you, charisma. Yeah, so make sure that we get the 12 and the 15 on the same side, and then c squared on the other side. Something else I'd like to point out to you, I maybe should have on the other side. Do you remember our Pythagorean triples?
Yeah.
One of the Pythagorean triples was a 5, 12, 13. Okay, so when we know, like if you can memorize these, if you know that one of your legs is 5 and your hypotenuse is 13, I mean, we proved it with Pythagorean theorem, but if you can memorize these through a Pythagorean triple, you would have already known that the last remaining leg was going to be 12. If, actually, no, we don't, 4, No, yeah, this one's not. 144 plus 225 is equal to c squared. So that would be 369. Take the square root of both sides. Does that give you a decimal? Okay, so if you're being asked for a decimal, meaning that the question would tell you to round, cool, write the decimal. But I'm assuming that if that time were to come, as long as you have a calculator and you know where to find your square root button, you'll be fine. Yes, sir. Well, because yeah, you have the squiggle. What? Oh, I'm guessing you have math. You're blessed with something called math grid. So your calculator does for you what we're about to do by hand. Good. Yes. I'm guessing Jair probably took it. He's obsessed with you. No. Does anybody have Josh's paper?
I just took the paper out.
Yeah, and I don't have any more of the packet. Guys, can anybody, if you took his paper, can you please get it back to him? It's a paper. Nobody took it. Just write it down. Just,
Oh yeah,
Yeah, calculator.
exactly what it is.
all right, so let's do a factor tree with 369. The first prime number that you can factor out is a 3. That leaves you 123. 3 can be factored out of there also. Is it 41 times? 41 is prime, so you're done. So I can bring out a pair of 3s. So 3 square root of 41 is equal to, if they ask you to round, you would just round with a calculator. If not, you should know how to simplify a fraction. No, not simplify a fraction, simplify a radical. If I said fraction, I misspoke. Determine whether each set of numbers is a Pythagorean triple. But we already know this one's going to be because I told you it was going to be. But the way that you would prove it is, well, it's 2 questions. First, they want to know if that makes a right triangle, and then if it forms a Pythagorean triple. So the way that you would prove that it forms a right triangle is to put the numbers into Pythagorean theorem. If you end up with 2 equal sides, then it's a right triangle. In addition to being equal, if there's no fractions or decimals, it's a Pythagorean triple. 64 plus 225 have to be equal to, I think it's 3 now. End up with 2 equal sides. But the answer to the first question is yes. Yes, it's these 3 sides form a right triangle. The answer to the second question, if it's a Pythagorean triple, is are any of these numbers fractions or decimals? So that means yes also. Now we already knew that because I wrote it on the first page. let's do the same thing with this. Now here we already know the answer to the second question. We know that this cannot be a Pythagorean triple, but that doesn't mean that it can't be a right triangle. I know we don't like fractions, but the good news about this one, the good news about fractions is that fractions are not that evil when it comes to exponents. Because all you gotta do is the exponent on top and the exponent on the bottom. What's 1 times 1? Good. 5 times 5? 1 times 1 is 1. 7 times 7 is 49. What happens if you square a square root? Nothing. They cancel it, so you just get the 74. And then 35 squared is? I'm just squaring every number. 125. What is it? 1,000. 125? Huh? 35 times 30. You disagree that 35 times 35 is 1225? So now the only thing left to do, and this would be, I guess, the hardest part, is that you have to know how to add fractions. What is the least common denominator of 25 and 49? If you're not sure, then just find a common denominator. Instead of finding the least common denominator, find a common denominator. What is 25 times 49? Times, yeah, just multiply 1225. Sorry? 25 times 49 is 1225. Perfect. 1225, 1225. Since on the bottom to get from here to here I did times 49, I gotta do that on the top, that gives me 49. Since here I had to do times 25, 1 times 25 is 25. Add them up and I get 74 over 1225 is equal to 74 over 1225. Did I end up with 2 equal sides? Yes. So yes, I have a right triangle. Can you guys listen? But do I have a Pythagorean triple? Yep. No, because of the fractions. I doubt you'll see this on a test, but this is just free information Fridays. So it's on the house. Yeah, I'm not even charging today. It's just more stuff that you'll learn that you'll never need in life.
Pick it up on Thursday.
He's changed lately, huh? He's been a little extra obnoxious. Yeah, I used to like him a lot more.
Oh, I forgot.
The diagonal of a square measures 32 meters. What's the area of the square? All right, we haven't done area yet, but let's just draw a picture. Say that's a square. What do we know about a square?
All 4 sides are equal.
Okay, so if a diagonal, that you are supposed to know, is 32. And if all the sides are equal, can I call this x, 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 because they're all the same?
No. Yeah.
And we also know that squares have right angles, right? So if we then kind of erase this, because I don't really care about the square, I care more about the fact that with that diagonal I made a right triangle. I can now use Pythagorean theorem to find x. But you're thinking, hey, but Mr. Romero, you told me that Pythagorean theorem can only be used if you're missing one side. How many sides are we missing here? 2. If they are the same, then you can still use it. Because the fact is they're going to be like, I'll show you. What 2 sides are these?
Legs.
They're the legs. So I would write x squared plus x squared. X squared plus x squared is equal to 32. So even though there's 2 different unknowns, yeah, they can be combined.
32.
Oh, sorry, thank you. So 2x squared is equal to, what is 32 squared?
1,024.
1024? Yes. Okay. And then we'll go divide it by 2. squared is equal to 512. Take the square root. I'm doing the same thing that I've done on all the other ones. Nothing like when we started. Getting repetitive, I usually go a little faster. Huh? Yeah, you do get a decimal, but I'm kind of wondering how to approach this because I don't want to confuse you guys too much. Because the thing is, if you understand what the end game is here, well, like, what did the question ask for? It asks for the area, right? And I realize that we haven't covered area, but does anybody here know how to find the area of a square? That's a perimeter. Okay, but some people would say length times width or multiply two sides. What I would offer is, well, if all the sides are the same. Why do you think they call it a square? What are you going to do? You can just get one side. You can just square one of the sides. Like when you look at textbooks will tell you that the area of a square is just one side squared. So what I'm telling you is, all right, yeah, we want to take the square root of 512, but to find x. But if all we're going to do is get this side and plug it into that formula where you're going to square it right afterwards, why would we waste our time with decimals or trying to simplify that? Because once you plug a square root into a square, what's the square going to do to the square root? Shaughnessy? What is the square going to do to the square root? It's going to cancel it. So, yeah, maybe I never found out exactly what x was. Well, I do know it's the square root of 512, but instead of having to simplify that, if I'm going to have to end up squaring it, the area just ends up being 512 because this square here goes, oh, Mr. Square Root, I don't like you. Go away. You go to your phone. And then I'm just like, okay. Do you understand what I'm saying there, or do you want me to actually find x and then plug it in? And you end up with the same thing. And the teacher. Teacher was good. How many twos can I bring out? Oh, it's a factor tree. I just did a factor tree with 512. 512 is 5, 6, 7 is 8 twos multiplied. 32, 6, 7, 8. Yeah, it's 9 twos multiplied times each other. 2 times 2 times 2 times 2 times 2, 9 times gives you 512. So I can pair up 4 pairs of the twos to come outside. What is 2 times 2 times 2 times 2? No, 4 twos. Like, these are inside the radical. This is like the same thing as saying x is equal to 2 times 2 times 2 times 2 times 2 times 2. Huh? Well, I know, but she's not understanding where I'm getting that 16 from, so I'm just showing you. Like, if I multiply 2 times itself 9 times, I get 512. So, for every pair, I can bring it out once. So, I'm bringing out 4 twos. 2 times 2 times 2, like 4 times, is going to be 16. It stays on the inside of 2. Now, the point I was getting at is once you get this, and multiply it times itself, once you square it, you're going to end up right back at 512. The question was asking you for area. It wasn't just asking you for x. Yes, no, maybe so. Mickey? What is the length of a diagonal of a square whose area is 64 centimeters squared? So now we're going backwards. They're giving us the area of a square. And then they want to know the length of a diagonal. Well, if I want to know the length of a diagonal, I would like to know the length of a side. The side of the square, Yesenia, is the same as the leg of a right triangle. If to find the area of the square we squared, how would you go backwards to find the side if they give you the area? Square root. What is the square root of, let's just call this x? Square root of 64 is 8. So I know each of the sides are 8. I know this is going to be 8, and I know that's going to be 8. How would I then find the diagonal? Well, that means then that 8 squared plus 8 squared is equal to the diagonal square. I plugged in the 8s where the legs go. 64 plus 64 is equal to b squared. 128 is equal to b squared, but now Wyatt gets to play with his newfangled calculator. Yes, but let's understand why though. It's called a square root. So if you when you put it into a conventional calculator, it's going to give you a decimal, so we do a factor tree. Yeah, they also call it peak Nike sign too. What is a prime factorization of 128? If I were to rewrite 128 as a product of prime numbers, what would I write it as? If I were to rewrite the number underneath the square root is 128. If I were to rewrite that as a product of prime numbers, this is algebra 1. This part of it is not new. What would it look like? How could I rewrite 128 as a product of prime numbers? It's like literally on the board right now. It's 2. These are prime numbers. 2 times 2 times 2 times 2 times 2 times 2 times 2. How many 2's? 7. Here. Wyatt, use your new calculator. So what's 2 to the 7th power? 128. Mickey, how many 2's can I bring out? 3, yeah. And what's 2 times 2 times 2? 2 times 2 times 2. If the question asks you to round, then just use the calculator to round. Why you're going to be in a world of trouble? Because now you have to know how to change your settings to give you a decimal instead of. Okay. Questions? All right, why don't you guys do this one on your own? And raise your hand when you got it. I realize the answer's there, but I don't want it as a decimal. I want it exact. Can you find the exact length of a side? Find the length of a side. It's the same thing that we just did right now. Actually, wait, let me see. Sorry, it's the same thing we did here. But they're giving you the diagonal. And then you find the length of a side. Instead of the diagonal being 32, the diagonal is 5. Just try your best to follow. That's rounded. I don't want it rounded. Sean, let's see what you got. Let's just do it together, even though you guys have been clamoring for more of these types where you can practice on your own here. So if this is S, this is also S. When you plug it into Pythagorean Theorem, it's S squared plus, oh man, my S's look like 5s. Okay, these are S's, and then, there, that's a 5. What's S squared plus S squared? 2x squared, just like the 2 problems ago. 5 squared is 25. And now here's where everything is going to go haywire because you guys are too overly reliant on calculators. The one we did 2 problems ago had a 32 that was being squared, which was an even number. So when you divided it by 2, no big deal because there was no decimal. But now here, you have to use a calculator. And by the way, next week you'll learn the shortcut for these. We're not doing it a long way. Instead of being too reliant on the calculator, Mohammed always says to leave it as a fraction. If you can't divide, leave it as a fraction. Vicky, you writing all this down? Huh? He did. Mohammed hates decimals. Huh? Not if it isn't absolutely necessary, yeah. Or they're telling you to round. How do you get rid of a square? Okay. These are S's. I'm sorry. I apologize. This one here is a 5. So I do have the S that I wanted. And just like the same way that when you had a square, you distributed it, you do the same thing with a square root. What's the square root of 25? Nikki? No, this is a 5. But then on the bottom, I cannot take the square root of 2 because that gives me a decimal. So I leave it as square root of 2. Well, here's also something you should have learned in Algebra 1. You cannot leave a fraction with a square root on the bottom. So you do something called rationalizing a denominator, where you multiply it by square root of 2 over square root of 2. You never did that in Algebra 1? Because the way that, what's anything divided by itself? 1. So in reality, what am I multiplying the fraction by? I'm multiplying it by 1. And anything times 1 is itself, right? But by doing it this way, what happens if you multiply the same square root times itself? The square root cancels out. So you would just be left with just 2. What happens on the top? You just leave it that way. So you would have 5 square root of 2 over 2. And let's skip to some word problems. A tent is supported by a guy rope tied to a stake. What is the length of the rope? So what they want to know, let's call this X. They want to know that X there. If we ignore the tent, which side in the right triangle are we looking for? The hypotenuse. So what are the length of the legs? 8 squared plus 6 squared. Yeah, or I'll get crazy and say 6 squared plus 8 squared is equal to. It does not matter. Now, if you get really good at this, actually, I can tell that there's a Pythagorean triple. If you go back and you're like, whoa, Mr. Romero, you didn't have a Pythagorean triple that had any 6 and 8s. It's a multiple of this. What's if I get these two and multiply it by 2, 3 times 2 is 6, 4 times 2 is 8. Therefore, what am I going to end up getting? What's 5 times 2? I'm going to end up getting 10. Let's do it. Let's prove it because I don't want to confuse anybody by doing shortcuts. 6 squared is 36 plus 64 is equal to x squared. 100 is equal to x squared. 10 is equal to x. Yeah. From what I've seen with my algebra classes, because they've had more word problems than you guys, these tests tend to have points given for contextualizing responses, meaning not just leaving it as x equals 10 when there's a word problem involved. What does that mean? So at the end, you would say something like, the guy rope is 10 feet long. They were measuring in feet. If the supporting stake in problem 1 were 15 feet from the tent and an 8-foot tent pole, what would be the length of the guy rope? So now what they're saying is if we go back over here, let me actually copy and paste this picture. So what they're saying is with this same picture that's here, if we were to change this to 15 and then this to 8, just to save us some time here, because we'll still do more examples. Can anybody tell me how long this is going to be without having to use Pythagorean theorem? It's a Pythagorean triple. How did you get x equals 17? You just guessed. It's a Pythagorean triple. It's a Pythagorean triple. What type of triangle is that? Vicky, you look like you want me to use Pythagorean theorem. I'm gonna do it for making faces. I don't want that. Which side are we looking for? Alright, so 8 squared plus 15 squared is equal to x squared. 64 plus 225 is equal to x squared. Add them up. 289 is equal to x squared. And then you would write at the end the guy rope is 17. Stephanie is planning a right triangular garden. She marked 2 sides that measure 24 and 25 feet. What is the length of side N? Well, what type of side are we looking for? Yeah, if we're looking for a leg, I believe this is also a Pythagorean triple. So if you memorize those, you can maybe save yourself some time. And I would actually accept it. If you give me an answer and you state that it's because you have to write down it's a Pythagorean triple, it shows me that you know what you're talking about. Tell me what N is going to be. 7, 24, 25, but let's prove it anyways. So N squared plus 24 squared is equal to 25 squared. N squared plus, is that 576? Yes, 570. Plus 576 is equal to 625. Now to get the N by itself, we got to do minus 576 on both sides. So N squared is equal to 49. And then when you look at that, we can write how long N is equal to 7. builder needs to add it diagonal braces to a wall. The wall is 16 by 12. What's the length of each brace? This is actually also going to be I'm gonna show you the work on Pythagorean theorem, but just for fun. Basid's having fun, I can tell. He said he was sorry yesterday, so I'm sure he's sorry. Can anybody tell me without doing it what the diagonals end up being? So those are the legs. The diagonals, the hypotenuse. Addy, do you know? Can you at least tell me what type of Pythagorean triple that is? There's 4 types. Either you're going to tell me it's a 3, 4, 5, a 5, 12, 13, an 18, 15, 17. It is a 3, 4, 5, yeah. It's just that's just a 3, 4, 5 that's been multiplied by 4. The 3 and the 4 have been multiplied by 4. So if I also multiply the 5 by 4, that's going to give me 20, yeah. But that's just 12 squared. Make sure that where you're gonna mess this up. Let's see, what do you want to call this? Diagonal square. Where you're gonna mess this up is if you plug the numbers in the wrong spot. Just make sure that diagonal goes where the hypotenuse goes. 144, 256, 400 is equal to diagonal square. Why it's exciting? Because he gets to use his calculator to find the diagonal square. What do you like better, Charisma? Compasses or Pythagorean theorem? The diagonal at the right shows a post that was broken. What was the original height of the post? Ooh. It's a trick question. So this is a pole that snapped, right? So okay, the way it's drawn, okay, obviously this is at a right triangle because we assume that the pole was erected vertically. So that's a right triangle. What side on the right triangle are we looking for? We are looking for the hypotenuse, so let's find it. 2 squared plus 18 squared is equal to, yeah, let's do this. X squared. So 4 plus 324. Make it easy. Put that in, if you take the square root and put that into your calculator, what are you going to get? Yeah, you're going to get a decimal. Now, I would guess, just because I know where this is headed, that more than likely on a test, this would tell you to round. I doubt this one would ask you to keep it exact. This one would probably tell you to round, but I feel like you guys are comfortable with the whole simplifying thing. So let's just do another tree just for the fun of it. 150 and 14 is 164. Divide by 2 again is 82. Divide by 2 again is 41, and 41 is prime. So I could bring out a 2. So if I wanted to simplify, this would just be a 2, and then the 2 and the 41 stay inside. So that would be 2 square root of 82. But partly because this is a word problem, word problems are more predisposed to rounding. And then because I know what I'm going to have to do now, let's just actually go back and just round. What is let's go to the nearest, they don't tell us, but let's just go like to the nearest 10th, I guess. What is the square root of 328 to the nearest 10th? Is that, everybody agree with that? Okay, so let's say 18.1 is approximately. So now, when they ask us for the original height of the post, what should we do? Add 2 to it, sure, because if I were to somehow fix the pole, the broken part is the 18.1, but then there's still 2 feet that are standing. So we'll just say that the pole was 18.1 plus 2. If I would have left the radical, then the addition would not be possible. And actually, this would be rounded. Here, Wyatt, these are your squiggly lines. Round. Yes. Oh, mother. Okay. That makes a difference. I did not catch that. Bad news. We need to, that could be why we got a decimal, yeah. Wow, that's my bad. That's like a big cardinal sin there. You should always check. All right, so that means that this problem also incorporates unit conversions. Now, they don't tell us what unit they want us to end up in. Well, is it always easier to go to a smaller unit or a bigger unit? Smaller, yeah, because you end up multiplying, and then that way you don't get decimal. So, how many inches are in 2 feet? 24 inches. 12. And yeah, that's actually gonna make this into a. This is also a Pythagorean triple. But we'll just show you. 18 squared plus 24 squared. There's gonna be a 3, 4, 5. Let's call this x again. 18 squared was 324. 24 squared is 576. If you add these up, you get 900. Which that is a perfect square. It's just 30. But remember, this is 30 inches. So if I add that to the part that broke out for the pole, what would I be adding 30 to? 24, not 2 yet, because this is 10 inches. So I could say that the pole is 54 inches, or if I wanted to go back to feet, what would I do to that 54? Divide by 12, but that's going to give you a decimal. It's a pretty small pole. Not even 5 feet off the ground. Alright, we can do a few more. Thank you, Hattie. Hey, look, we're flying a kite. Anna has let out 50 meters of kite string. Yeah, check the units. They're both meters, so that's good. If Anna is 35 meters from Emily, how high is the kite? So we want to know the height h. It is a leg. So I'm going to say height squared plus 35 squared is equal to 50 squared. Height squared plus that was 1225 is equal to 2500 minus 1225 minus 1225. Does that also give you 1225?
Yeah, no, it gives
1275. Did it say the round? Not. So I think this should give you that. What's the square root of 1275? Yeah, if they let you round, then actually, yeah, there's a word problem. So on a word problem, rounding is a little bit more acceptable. What'd you get? Okay, so 35. And this would be in meters. You got to change your setting to take off math print. You might have a button that like switches between radicals and decimals. It'll look like an arrow. It'll say something like a convert to decimal, something like that. Okay, here. We'll make this. Maybe we can do 2 more. What's the height of the parallelogram? So if we ignore all of this part here of the parallelogram, if we just ignore that, we have a right triangle. Is what part of the right triangle is the height? Which side? Leg. It is a leg. So height squared plus what's the other leg? 9. Good. Is equal to 15 squared. It looks like it's also going to be a Pythagorean triple. Height squared plus 81 is equal to 225. Minus 81 minus 81. what is it, 144? Yeah. Which means the height is just 16 meters. 12. Oh, I'm having a bad day. Or pretend it didn't happen. Thank you, Jair. 12. See what happens when you have sleep deprivation. Make mistakes. See if I have a better one. Alright, here, let's do the last one. Go to the end. We'll do the very last one. That'll be it for today. Yeah, because now it's a word problem, but there's no picture for you. So we have to draw the picture. A ship. A ship leaves the port and sails 12 kilometers west. And then 19 kilometers north. How far is the ship from the port? Let's just call this a deeper distance. Which side of the right triangle are we looking for? Good. 12 squared plus 19 squared is equal to distance squared. 144.
What distance?
Huh? A leg? No, man. Distance is a straight line. So if the ship started over here and then went this way and then that way, how far is this going?
Oh,
They all what? Okay, but what's 19 squared? Somebody help me with 19 squared. 3 something? 361. Okay. So 505. Take that mental math. And then yeah, this on a word problem. Even though this doesn't state one way or the other, on a word problem, rounding is a little more kosher because it's there's units. Square root of 505. What do you get for that? 20. Does anybody now feel comfortable with Pythagorean Theorem? You don't feel comfortable with it, Hattie? Jake. State Farm.